to you. All right. So as Jacob mentioned, one of the biggest issues that we run into is the performance of our workbooks, and we can have the ability and have the knowledge behind all of these different chart types to create such a great view, but face it, I mean, we're humans and our attention span is not that great. And so if we start to build out these workbooks and present them to our users and they take minutes to load, we're not going to want to wait for that information, especially when you're trying to increase the user adoption of Tableau in your organization. We need to try and make the rendering time and also the interaction time of Tableau as quick as possible, because one of its best features is the fact that it is self-service business intelligence. So we're allowing our users to make their own selections. So what we're focusing on today is improving the performance of the different workbooks that you may have, starting from the data side and then going all the way down to what happens when I create separate dashboards. So starting out with our data, we have to think about keeping the analysis simple. So we have our little phrase that we always use, you want to keep it simple. Thinking about keeping it simple means really taking a look at the data that you're using, taking a look at what it is you're trying to create. Of course, when we start working inside of Tableau, we may not be very familiar with the data. One of the best uses of Tableau is to explore our data. But once I have my connections and maybe I have some of my visualizations created, I'll start to notice if there's information that's just not being used. So maybe I have 20 years worth of data, but I'm only using the last 5 years. We definitely want to work with subsets of our data to keep the analysis simple. Don't try and throw everything into Tableau and keep it there. Once you know exactly what you're using, we can start to filter out those different sources. And I can walk through examples inside of the Tableau tool itself to kind of give you an idea of where some of these options might be located. We want to bring in only the data that we need. So regional information is another good example. What if I'm only looking at the southern region? We can definitely create our data source filters. A data source filter is going to apply to the entire data source connected to this workbook. So I'm not going to be processing all of the extra information that comes along with my entire database. We can describe and explore our data. So I'm going to show you an example of how a description of a field could give us some insight into why or why not we may want to even use that field. Some of the things that describe can provide for us. Removing those unused columns. Again, we're thinking about making a smaller amount of data to work with. So two things that we want to take into consideration. Making your data source more narrow. More narrow means we're removing some of those columns. Or we can think about making the data source shorter, which would be decreasing the number of rows that we have in our data source. And we've got different examples. We can aggregate our data. Also, filtering would make it shorter. Anytime that you can remove unnecessary fields from the view, you're definitely on your way to improving the performance. Now, creating a published Tableau data source, which I'll show you an example of, creating that PDF file is going to give you the opportunity to sort of set up exactly what you want your team to use from the data source. So business intelligence has always been about one version of the truth, and this holds true when we're working with Tableau data sources, because I want to be able to set the metadata, so the default aggregations and also the default number format. I want to be able to set that information once, make one copy of optimized data for my team to use, and then have everyone connect to that Tableau data source. Using extracts is probably one of the most important things to think about when you're thinking about connecting to data, because your extract is optimized to work inside of Tableau. So it's a columnar data store that we're using that Tableau can directly link out to. So consider having to link out to your actual database versus connecting to this extract. We've seen significant performance improvements just by taking an extract of the data source itself. And I'm going to jump into Tableau for a minute, just to sort of talk about each of these things individually and where you might find those options. So what I have here is just a connection to Superstore. This is our Excel data source, but we do have options to connect to databases, as I'm sure you're all aware of. The first thing that we mentioned was creating some sort of filter for the entire data source itself. This can all be done from the data source connection in the bottom left-hand side of your screen. That's going to take you back to your data connection window. So this might be something that you do at the very start of your process of analyzing your data. In the upper right-hand corner of that connection screen, we have our data source filter, and that's going to allow us to filter the data before it's brought into Tableau. Don't require Tableau to process extra information if we don't need it in our analysis. I can describe certain fields. So in Tableau version 9, we have our description directly inside of the data connection screen. Using the drop-down arrow for any of these fields gives me the describe button. Now, something to keep in mind, if I have an object such as a ship date, some sort of date field, if I have different order IDs, that's a unique identifier for every single record in my data source. I'm expecting to see lots of values in these fields. But for instance, ship mode, if I just want to see the values of our ship mode field, choosing the drop-down arrow and then selecting describe would give me some information. A couple of things about this describe field. It's going to give me the remote column name and the remote column type. So that's just a pro tip, an extra little trick here in case you do need to speak with your DBA about this particular data source. There are some changes that we can do inside of the database itself, including creating new fields or creating stored procedures or views. And so we may want to work directly with our data team before we bring this into Tableau to kind of optimize the data connection process there. Looking at the individual members of a field, I want to see how long it's going to take Tableau to load in this specific column. If you choose the load button in the bottom left-hand corner, it gives you the 4 distinct members of that particular dimension. But as you would expect, the more members that you have, the more unique combinations that you have, the longer it might take Tableau to bring in that column. So exploring your data from the data connection screen is the first step in understanding only what needs to be in our analysis. Once we've moved over to one of our worksheets and we do have our data source connected, I've mentioned taking a Tableau data source or a Tableau data extract of that particular file. Those can both be found if you right-click on your data source in the upper left-hand corner. So if I right-click on orders from Superstore, I have the ability to add it to a saved data source. Again, that's our TDS file. It's one common copy of the data, and it's keeping all of those metadata changes. Or I can choose to extract the data. And when I choose to extract the data, you can see all of the options that are available. So filtering the data from an extract would give you the ability to shorten the data source itself to limit the number of rows. Aggregating the data for visible dimensions creates what we call an aggregated extract. It's taking all of the lower level of detail that we don't need in our analysis, and it's rolling them up. So it's making a shorter or fewer number of records. It's going to process a little bit quicker. What we do know about our extracts is that they're a static copy of the data itself. And so if you're using Tableau Server, you may want to schedule the extract to be refreshed. And maybe I would want the extract refresh to run overnight. So in that way, even though my data is continuously updating, my extract could update on the schedule as well. So I get the performance improvements of taking an extract, while at the same time, I get the newest data maybe nightly or even up to every 15 minutes. So giving those options inside of the data extract is really, really valuable. Also taking a sample. Now, I'm connected to an Excel database at the moment. I'm connected to an Excel spreadsheet. But if you were connected to an actual database, if you had entered credentials for a database itself, I could take a sample or a percentage of my particular data source. So if I just want to work with a smaller amount, that is something that's available inside of our extracts as well. Any questions or suggestions, comments, experiences that you may have had working with extracts in the past, how they've increased the performance of your data source, or any questions about specific data connections?
So I have a question, not specifically on extracts, but on saved data sources, TDS. Can you save that to server and have people consume it from there rather than send it out?
So the Tableau data source should be able to be published to Tableau server, very similar to the way that you would publish your Tableau data extract. So the idea behind it, the concept behind it is that if the file is published to Tableau server, then multiple people from the organization would be able to access that Tableau data source.
Cool.
So working with a smaller amount of data is the first step that we're going to take to sort of improving the performance for the entire connection to that data source itself. We've mentioned our data source filters and how a filter can help us to reduce the overall amount of data, but we also have other considerations that we need to think of when filtering. The basic idea behind it, I want you to think about the process or the query, that extra question that Tableau has to run whenever we're asking the tool to filter the amount of data that we're looking at. So the first thing would be minimizing our quick filters. Now, quick filters are named quick filters. It's an easy way to get to our data, and we would assume that they perform very well in addition to their name. But if we think about the quick filter itself, we're asking Tableau to load all of the potential values of that quick filter. Because we're giving a list of information that a user can choose from, that's an extra step that Tableau has to do. It has to load up the available values, and then it has to present it to the user for selection. So you may want to minimize those quick filters that are being used. Our suggestion, instead of using quick filters, you could potentially use a dashboard action. And I'll show you how the same idea applies within our quick filters and our dashboard actions, but why they may be processed a little bit faster. A lot of you know the idea of cascading quick filters, including only relevant values. So I have an example here that I want to show you. When I'm working with some sort of logical hierarchy, the idea that I have particular states that belong to a specific region, a lot of people ask the question, well, can I have only the states within that region appear once the region is selected? And the answer is yes. The idea of cascading quick filters inside of Tableau is done through our quick filter selection. So if I choose the drop-down arrow in the upper right-hand corner, you may know that you can select only relevant values to create this cascading quick filter idea. However, if we choose only relevant values, Tableau's first having to process which region it belongs to, and then it's having to load all of the subsequent values for that particular region. And the issue there is that we're adding an extra step, and anytime that you're adding that extra step, the performance of your workbook can slow down just a bit. So we want to keep in consideration, keep in mind, how many of these cascading quick filters we're actually using. Our alternative solution to this, instead of using the cascading quick filters, what if we bring this into a dashboard and we use dashboard actions instead? The idea is that I have this dashboard here, and I have just a quick tree map with my 4 regions. The first perk of using this dashboard action is the fact that it's giving me information here. I know that the value that I've created is based on sales, so the West is my highest selling region. In addition to providing the visual information, I can also use my region worksheet as a filter. So you may be aware that to create those dashboard actions on a dashboard, all I need to do is check the selection for use as filter. Instead of using those cascading quick filters, I can now click on a square or a section of the tree map, and it's going to filter my bar chart down at the bottom for only states within that particular region. So we suggest this as a better approach to those cascading quick filters. It's going to perform a little bit better. Looking back at our quick filters, we do want to avoid any high cardinality quick filters that we're looking at. So for instance, multi-select or drop-down list. Again, if I give a drop-down list of every single customer that I'm selling my product to, or a drop-down list of every single product that I'm creating, that's going to be a lot of information for Tableau to have to render or load. You may want to use some sort of single value selection, maybe a single value drop-down list, so on. So avoiding those types of filters would be a good idea to improve the performance as well. Also including those context filters. Now, context filters are a bit different. They're pretty similar to the idea of a cascading quick filter in the sense that I need Tableau to process filter A before it processes filter B. But the issue that we run into sometimes with context filters is the idea that a context filter gives us a temporary table. So for context filters, Tableau is having to create temporary tables. Because of this extra process to create those tables, they can become a little bit slow when we're looking at them in terms of our entire workbook. So a context filter is created. If I have a filter here on my filters card and I right-click on the filter in the filters card, I could choose Add to Context. But we caution our clients, our users, with the use of this context filter because of the addition of those extra temporary tables. Keeping the ranges simple of a quick filter is also something to keep in mind. When we started to take a look at our data source, I did mention that we had fields like date fields, maybe even our numeric fields. If you think about an axis with 4 years worth of data, if I have this at the daily level, the monthly level, or the hourly level, that's going to be very, very, very large. It's going to be a very large amount of individual values. So I have to consider every single day over all 4 of these years. The more values that I'm asking Tableau to load inside of that quick filter, the longer it will take. So maybe we would want to avoid using the entire or full range of our date information. It might be better if I bring my date field over to the filters card. It might be better to look at this by certain years or by just certain months of the year instead of providing the entire full range of dates. Again, this is all going to be based off of the size of your data, but these are all a combination of things to keep in mind. And then taking a look at our user filters. So user filters can be used with Tableau Server to sort of pass information about the person viewing this particular dashboard. So if I only have access to the southern region, so that is the only information that should be available. But if I am using those user filters, we have to think about the impact on performance. Tableau Server can't share connections or query caches if the user filters are being used. And so we have to consider maybe using Active Directory groups instead of individual users. I would maybe want to assign specific people to a view instead of just saying an overall blanket of, well, hey, all of these people can see a specific subset of the dashboard. One thing that we can do, an approach that we would rather take instead of using these individual user filters, there may be a version of my data source that I can aggregate that will be a summary level that everyone can see. So I would definitely want to start out at this summarized level and then move into a more specialized dashboard for a specific group. And so having to limit the amount of data for that specific group from the summary dashboard would potentially be a better approach than using the user filters. Be careful when you're working with those user filters. Any other additions or comments, questions about creating filters inside of your worksheets for the dashboard? We want to continue thinking about our data sources and how we can connect to data Tableau has a very, very efficient data connection screen that gives us all of the selections we may need until we start talking about combining tables inside of our database. So we are aware that Tableau can create joins, but we do know that in some data connections, those join types are limited. Maybe I need a full outer join, but Tableau isn't giving me that ability. The first thing that we have to think of is, what are we combining together? What are we creating? How many joins are we asking Tableau to perform? Keeping in mind that Tableau's main priority is to be your data visualization tool, you would want to do as much of the work, as much of the data work in the backend data source as possible. So instead of writing custom SQL to make some sort of union inside of Tableau, I could do all of this backend data work inside my database itself, and then create a view or a stored procedure to connect to. And that would give us a little bit better performance than having to use the custom SQL query itself. Because the idea within custom SQL is that whatever we write inside of the custom SQL connection is going to have to be re-queried. That question is going to have to be asked again and again every time that we interact with Tableau. And so having to run this individual query that many times could slow down the performance. Also, this would be a big factor if we have parameters. We do have the ability to include a parameter inside of that custom SQL statement, basically asking our user to make selections before the data is rendered. But if we have those parameters, Tableau wraps that custom SQL inside of a subquery that lots of databases don't really handle very well. So we would want to think about, again, doing all of this work on the data side itself, doing this work in the database, and then connecting to some sort of view. If you are going to write the custom SQL statement, you can think about avoiding maybe useless clauses, such as our order by clauses. Tableau is going to resort the data once it's loaded. We know that we can do all of this sorting inside of Tableau as well. And so those order by clauses, those useless clauses, wouldn't need to be included in the statement itself. The final suggestion that I'm going to give you when you're working with custom SQL, think about the fact that I'm writing the SQL statement, it's loading the data for the first time, I have all of the information that I want to analyze, then we would take a Tableau data extract. So our suggestion is to usually work with an extract after you create the custom SQL statement, because then Tableau is going to be able to use that saved version of the data and just simply requery the saved version instead of having to run the entire SQL query again. So that would be a definite suggestion. If you have to use custom SQL, be sure to use a Tableau data extract as well. Does anyone have instances or experiences with using custom SQL that they've seen maybe slower performance? Any questions or suggestions for using custom SQL? So all of the things that we've been thinking about so far, they've had to do with the connection to the data itself. How much data are we bringing in? How much data do I need to manipulate or work with at any given point? This is going to hold true when we're working with our calculations as well. Tableau's main priority, again, is to be your data visualization tool. We want to let it do what it does best. And although it can create calculated fields, and although we use them quite a bit, creating those calculated fields inside of the data source itself might be a better option. So that's the first place that we want to look. Am I going to use this field a lot? Could it be created inside of my data source? Now, of course, we've worked with a lot of clients, and so we see people that say, you know, yes, this field could be created inside of my data source, but that requires a support ticket, and that support ticket might take 6 months, and guess what? I don't have 6 months, so I'm just going to create the calculation inside of Tableau. Perfectly fine. Definitely understandable scenario, and so we have to keep in mind some of our considerations with calculated fields. You want to think about the data type. The data type of the field that you're creating has a big impact on its performance. And so we normally say that numeric calculations or Boolean calculations, those are going to be our quickest calculated field. So a Boolean only has a true or false outcome. That's relatively quick. Our float or our integer values are also going to be numbers. Tableau does a good job of computing numbers. Moving forward, we would maybe want to look at a date calculation. Date calculations are treated similar to the way that numbers are treated. And then finally, our string calculation. So in most cases, a string calculation is going to take the longest amount of time to complete because of the fact that Tableau computes numbers a lot quicker than it computes character or text values. So consider the data type of all of the different calculations that you're creating. We want to limit our blended calculations. Now, most of you are aware that a blend inside of Tableau is different from a join. A blend is going to be when I am combining two separate data sources, whereas a join would be when I'm creating or combining two separate tables. When I'm working with blended calculations, Tableau is having to aggregate each of those blended sources separately and then combine them. So that's going to increase the amount of queries, the amount of statements that are needed to get that calculated field to work. So if you have lots of blended calculations, that could be slowing down performance as well. And then parameters. We just absolutely love parameters because they give us the ability to provide our user with some interactivity. So a parameter can give your user control over almost any piece of the visualization, but these row-level parameters that we're speaking about, for instance, if I had a parameter that's filtering between two data sources, because parameters do stretch across data sources, if it's filtering across two data sources, but it has 500 unique values for my user to choose from, if customer name is what's populating this parameter, that's going to take a long time for Tableau to process. So we would want to avoid any of those row-level calculations that include these parameter options. So the number of calculated fields inside of your data window are definitely going to impact the performance of the dashboard or the workbook itself. Another quick thing that I'm just going to mention here, if you create calculated fields that end up not being used, we can remove them. We would want to make sure that we are removing any unnecessary values, any columns that are not being used for our visualization, anything that we don't absolutely need. And that way, Tableau only has to run queries or interact with the information that's necessary. Once we have all of our calculated fields created, once we have our data source changed to be optimized inside of Tableau, then we want to think about the rendering process and the amount of time that it's going to take to load up these individual worksheets and these dashboards. We think about rendering for every single one of our worksheets. Let me go back into Tableau here. I'm going to create a quick scatter plot. Looking at my scatter plot is a combination of these two green continuous values, and we want to break up this scatter plot by our dimensions. So we can have lots of different circles, lots of different marks here inside of our scatter plot. Maybe we want to see some sort of relationship within our region, some sort of relationship within our customer segment. And I can continue to break down this information for the scatter plot, maybe even by customer name. I can take my customer name dimension, I can drag it over to the detail button, and Tableau has no problem loading the information initially. But I want you to always keep in mind the number of marks in the bottom left-hand corner of your screen. So this mark count is something that we need to be very careful about. Because of the consideration that this scatter plot is probably not going to be the only worksheet on a dashboard. If this is the only thing that Tableau has to load, it might not be a problem. I'm working with a relatively small data source. I only have 16,000 records. And so this might not be very difficult for Tableau to render at all. But if I have 4 scatter plots on a dashboard and they all have 2,500 marks, that's a different story. That's going to take Tableau longer to render. So we need to be aware of the number of marks. Our rule of thumb here is to keep it as simple as possible. Only go to the level of detail that you absolutely need. Maybe create some sort of hierarchy. Maybe give your user the opportunity to drill down into a lower level of detail. But for the first initial rendering of that worksheet, we want it as aggregated or as few marks as possible. So the idea behind Tableau is that we normally start off with some sort of summary view, and then we drill down into the extra information. And so that's going to give us the opportunity to keep that mark number, that mark count, smaller. The next thing that we look at is text tables. And you can hear me kind of giggling here. I've so many times had people come into the training room or walk into a client site and say, guess what? I have this Excel file, and my boss said that I've got to create this Excel file, this spreadsheet, inside of Tableau. And so we have our discussion, and I say, well, maybe we can think about ways to visualize it. Nope, don't want to visualize it. It needs to be a spreadsheet. It has to look like Excel. And that's when we kind of sigh and we think about it and how we can make Tableau create this information. And it is possible, but we want to limit those text tables, those very, very big spreadsheet type views, because think about all of the individual numbers that Tableau is having to load. So I can start to create some sort of crosstab here in Tableau, and I can have multiple different dimensions. Maybe I would have the region and then the shift mode. I would have subcategory information possibly. I could break this up by year of my order date. Tableau starts to build out our crosstab, and then we're populating with some sort of value. So I would add my sales information. All of these individual marks, all of these individual numbers that Tableau is having to load is going to take a while. It's going to take a longer time to render or process. Now, we've got different approaches to this. First of all, we have to think about, is this even very useful? We're using Tableau as a data visualization tool. So is it even necessary to show these underlying numbers? That would be our first consideration. Could we make this some sort of visual interpretation of the data? If the answer is no, if we need to show all of these individual numbers, then maybe we could filter before the spreadsheet appears. So the idea would be that maybe I have my information filtered by the East region, and this is again looking at the dashboard that I had created. If I filter to the East region, and then I filter to a specific state, Tableau would only have to open up or load the crosstab or text table with New York information. That would be a much smaller, a much more condensed text table than our original view, which would have been all of our information in our data source. So a suggestion for those text tables would be to filter before the text table is shown. One of those examples would be to place some sort of hyperlink inside of the tooltip that would take you to a more detailed dashboard. We should be aware that we can create our dashboard actions, and one of those dashboard actions could run on a menu or a hyperlink in the tooltip, where we would say, click here for detailed info about New York. This would take our user to a completely separate dashboard. If we had them formatted the same, they would feel like they're in the same tool. But this would be only the detailed information about New York, only bringing up those slow rendering text tables when it's absolutely necessary. So that would be a great suggestion for limiting those text tables. We also want to think about the images that we're importing, any custom shapes that we might be using inside of Tableau. Minimizing that file size is something to keep in mind as well. Keeping the images under about 50 kilobytes would be a good idea here. Also using maybe our transparent PNG files. It's going to give us a little bit more of formatting capabilities because we'll be able to pull in those background colors. They'll render a little bit better, a little bit cleaner, and then those PNG shape files are going to take up less space than, let's say, maybe a JPEG file. So if you are using custom images, those are two things to think about. The file size itself, the image size itself, and then maybe changing the source of the file, what type of file it is. We have to think about these rendering processes for each one of the worksheets because our worksheets do become a combined set of values on our dashboard itself. Looking at the worksheets that we've created, we are going to get into combining those worksheets on a dashboard and some of the considerations for working with your dashboard. But thinking about these local computations, and this is something that we should know. I'm just going to do a quick sketch here. For this quick sketch, we have to think about the life cycle that Tableau goes through. So if I have my interaction, let's say that this is my Tableau desktop. Tableau is having to interact with the desktop. It's having to send that information maybe out to some sort of database, some sort of data connection here, whether that's our Excel file or our data source. And then it goes through what we call the rendering and the processing tables. So this life cycle is happening inside of Tableau every single time that we interact. Now, the rendering and the processing tables, this is when these local computations are going to happen. So this is when our reference lines are built. This is when our table calculations happen. Table calculations are only going to be built off of what is in your worksheet at the time. And so what this means is that it's only taking into consideration what's in the temporary cache. So these local computations will impact the performance. We need to think about, if we are using Tableau Server, trying to get Tableau Server to take away as much of the computation as necessary. So I believe around 80% of that computation can happen on the Tableau Server side, kind of taking the burden away from the data source itself. But considering these local computations, we may want to limit these specific selections here. Blending, of course, has to aggregate those two data sources before they're blended together. So that's extra work that we're requiring as well. Our table calculations that we create are going to be dependent on the local machine that we're using. So they can take up a lot of memory. We have to consider the speed and the performance of the actual machine that we're working on when we're considering those table calculations. I would want to create my new calculated fields in the data source, like I had mentioned with our calculated fields section. Anytime you can move those calculated fields over to the data source, Tableau does a much better job of reading in the fields directly from the source instead of having to create it on its own. Now, for those of you that are using previous versions of Tableau, these queries that we were running, these questions that we were running, all had to run in a series, so one after the other. When we've moved over to Tableau version 9, we did see a performance increase because of this idea of parallel queries. If they are not dependent upon each other, they can run at the same time. But this is something that you want to think about as well, because these queries are not running at the same time. In previous versions, it can take a little bit longer. Any questions on those local computations, things that happen maybe after Tableau has accessed the database itself, or any questions on calculated fields? So we've sort of touched on each of the individual pieces that contribute to the overall final view. So the fields that are going to be created, the data source that I'm connected to. Again, I can't stress enough that taking a Tableau data extract could be a great idea considering performance. If you are working with that local or live connection to your data source, try out taking the Tableau data extract. One thing that we have seen on some client sites is that the initial load of the Tableau data extract itself is going to take a little bit longer. But then once the extract loads the first time, then we're going to receive the benefits of the extracted data. If we want, and if we are running Tableau Server, we have the ability to schedule that extract as well. And so then therefore, the refresh of the extract could happen during non-business hours whenever we're not using lots of resources from the database itself. So definite suggestion would be the use of those extracts. If you're using maybe over 300 million records worth of data, very, very, very large data sets, then you might be working with a database that is optimized to perform these queries. So we're assuming that anyone who has truly big data, very, very large amounts of data, has this inside of a data source that is meant to run that amount of data. Therefore, you may get better performance using your live connection, but for most of us, we aren't working with those large amounts of data, or at least we don't have to bring in the entire amount of our data source for our analysis. We can sort of pick and choose what's most important for analysis and use those connections within each workbook. But the final consideration when we're thinking about performance for the workbook is the dashboard layout and exactly what we're putting onto our dashboard. If that is our ultimate goal, if the dashboard is what we want to see, sorry about that. If the dashboard is our ultimate goal that we want to see, then we have to think about how much information we're asking Tableau to render our process. So the first thing would be the number of worksheets on a dashboard. You can see here that it just says limit the worksheets. Our suggestion is going to be maybe 4. Anything over 4 or 5 worksheets on a dashboard might take a while to render. But also think about the amount of information that I'm asking my user to consume. We don't want, in most cases, a one-size-fits-all dashboard for all of our different audiences. We want to build for a specific audience. We want to build for a specific business question or a specific purpose. We can really overwhelm our user with lots and lots of worksheets if we don't consider what's the primary purpose of the dashboard itself. Keeping in mind that you can have dashboards linked together, you can create filter actions that navigate between these different pieces. It's really unnecessary to place everything onto one dashboard, even though that's our natural instinct sometimes. So limiting the worksheets on a dashboard is a great idea. And then also choosing a fixed dashboard size. Choosing a fixed dashboard size means actually setting what is rendered each time that we open up the dashboard itself. And this is going to have a very big impact, especially if you're using Tableau Server. So this is our dashboard screen. And as you can tell in the bottom left-hand corner, we have different dashboard sizes that we can select from. Now, one of the versions of the dashboard size is automatic. And some of you may have used automatic before. It might seem awesome. I've also used it previously. It's going to fill up the entire amount of space on our screen that each user has. So it's basically going to fit to the user's screen, which seems fantastic, except it's not allowing Tableau Server to save any sort of cached information. We want to let Tableau Server do what it does best. We want it to keep some of this information already processed, but if you're using an automatic screen size, Server is not available. It's not allowed to do that. And so we suggest a fixed size. It can either be something that you set exactly. It can be one of the suggestions that Tableau has here, just as long as we're not using that automatic screen size. Another just visualization consideration when you're using an automatic screen size is that any object that is set to floating will not necessarily be aligned in the same exact way on a different user's screen. So one of our rules here, sort of rule of thumb, is to build for your smallest device. I can build this view in iPad landscape if I believe that my audience is going to be viewing it on an iPad. That's going to eliminate scroll bars. Our user won't lose any information, and then it's also going to be a fixed size. So therefore, when I publish this up to Tableau Server, it can sort of render or remember what size it's supposed to be loading in and some of the things that it's already taken the time to process. So that fixed size for a dashboard is really very important. We don't want to use automatic, especially if we're using Tableau Server. So sort of just a quick recap of all of the different things that we want to remember, some takeaway points, things that we want to really keep in mind throughout the entire process of building these Tableau workbooks. The first is keeping it simple. And this means smaller amounts of data, shorter amounts of data, more filtered, more aggregated views that we can work with, limiting the connection to custom SQL as much as possible. If you are using custom SQL, making sure to take that Tableau data extract, the snapshot of the information after that initial query, that initial SQL query has loaded up. Considering our calculated fields, only create the calculated field inside of Tableau when it's necessary. If possible, try to create that calculated field over in your backend data source and then have it load up into Tableau to kind of work with. For rendering and the amount of marks, again, keeping it simple. Less marks means less rendering time. We've got about 5 seconds of attention before our users say, you know what, this takes too long. I want to maybe use some sort of different tool that doesn't take this long. Why is Tableau so slow? That is what we're trying to avoid. For user adoption, it's very, very critical that the dashboard loads quickly and that we're able to interact with the view without having to wait long amounts of time. So consider the number of marks on each one of the worksheets. Consider how many worksheets you're placing onto a dashboard and how that's going to change the rendering or loading time for each one of these views. And then our dashboard size. Our dashboard size is another great thing to think about. You want it built in the fixed size, especially if you're working with Tableau Server. So I have this slide up here talking about our blog. Most of you may have been taking notes, or you may have been trying to remember or jot down these different things that I've mentioned, but luckily we have this done for you. So on our blog, we have this entire list of all of the different performance features that we want to take a look at. So keeping the data simple, keeping the filtering simple. I've given you a pretty in-depth explanation of each one of these topics, but we do have blog posts that are being created on each topic. So if you need to learn more, if you have never used extracts before, a great way to start might be looking at this using extracts blog and how it can really increase the performance of your data connection. So if you just do a simple internet search for the Tableau Performance Checklist, this will be the first thing that you find our InterWorks blog with all of these things listed. You might want to print it out. Down at the bottom, there's a PDF version. Print it out, have it at your desk to kind of take a look at when you're creating those dashboards. Have it bookmarked to go back and take a look. It's completely free, so it's a fantastic resource to have on hand. Now, if you aren't as familiar with some of these individual pieces, if you would like some sort of maybe tool that just kind of does it for you. I don't want to have to look for all of this stuff. I want something to do it for me. Jacob's going to talk a little bit about our power tools for Tableau and how those power tools can really be used to take into consideration all of these different performance features.